Let's now take a look at what you can see on the Eclipse quickly, and then we'll summarize about what we have covered about abstract classes, interfaces, and then some extra practice for you. If you go to the Eclipse, right, we spoke about example abstract classes, right? Let's now open another example project, example interfaces, right? Let me just clear the console over here quickly, right? If you open that, oh, wrong thing, under source, also again, we got model and we got tests over here, right? And of course, you got Cartesian points and also you got polar points. You can see both of them actually implements the point interface. And we got a point interface here as well. Right, of course, this one should be public and this one should be public, as I mentioned before, right? I just forgot to put them, okay? And that should be headers only. Okay, so let's now, I want you to use the debugger to find out dynamic binding, how it works at the runtime. So for example, if you go to the point tester over here, right? First of all, let me run exactly what's happening here. So you can see the values I'm setting up over here is exactly what you saw on the slides and the iPad notes. If I simply invoke this, you will see that in the case of Cartesian, we got 8.66 and also 5.00. In the case of polar, we also got the same. That means it's really the same points, but it's being represented by either the Cartesian versus the polar. Okay, that's something I want you to look into yourself to explore further. But what I want to show you is this. Let me now actually put several breakpoints over here. Let me just put this one here. Let's say P over here. And line number 19. Okay, and then I will say launch the debugger and switch. Okay, it's a very important exercise to make sure you can do it. Okay, let me just remove all the earlier expressions over here. Let me just remove them. Okay, let's say after the first line, you can see currently P is still pointing to null, right? As soon as after I try to initialize P to be a Cartesian point objects, right? If I say step over here, you can see P. You can see so we already I think we have already overridden the toString method. That's why you don't see the address anymore. But at least you can see it's a Cartesian point dynamically, and the ID, which should be unique, is 31. Okay, and if you open that, expand it, you can see we got X and Y. So that's the Cartesian representation. Okay, and what's more, I want to show you dynamic binding for sure. Right, you can definitely also evaluate the instance of. I'll leave you to that. Right, that's something also very straightforward, and we have seen that many times. Okay, go. Okay, so now let's say in the case where we try to call p.getX. So if I step into at this point, which version of getX should I see? Should I see the Cartesian version or the polar version? Well, depends on the dynamic type. In this case, it should be Cartesian point version. All right. If I say step into over here, we got some string argument, so that's okay. We can just say step return over here. Okay, let me step into once more. All right, you can see this is getX from the Cartesian points, which is good, right? It's exactly what dynamic binding is about. All right, let me now step over. Okay, so now we're gonna reassign P to be a new polar point objects, right? One thing to show you, you can see the P at the moment over here is Cartesian points, right? As soon as I say step over, its dynamic type is going to change, right? You will change from Cartesian point into polar points. Watch out the change. If I say step over, you can see it's now being changed to polar points over here, right? And of course, if you do the instance of check, now it should be the polar points rather than Cartesian point. And step over. Now I want to see, you can see what we saw before. P.getX at this point will actually show you the version of the earlier dynamic type, which is Cartesian points. But now, given that P, the context object, has polar point as a dynamic type, if I say step into, okay, I got a string builder, that's okay. I will just say step return. Whenever you step into something that you want to exit right away, because you want to see something a little bit later, in that case, you can just say step return. All right, I want to, by the way, just the string builder you saw was just about this part over here. Okay, I want to step into this one here. You will just go for a left argument followed by right argument. That's why you'll see this one first. Oh, sorry, the argument here. Okay, All right, let me say step into once more. You can see that's a get X, but now you can see the different version that's actually implemented in polar point class, right? Because the dynamic type is now polar points. Hopefully that makes sense to you. You really want to experiment such dynamic binding yourself rather than just on the paper. On the paper, understanding is very important, but also you should know exactly how this can be put into programming and practice. Both are equally important. All right, let me stop this, and then I'll let you explore this further. You actually got the 2 example projects for polygons and also for the points available to you. I'll rely on you to actually do the experiments yourself, okay? Especially debugger, and step into, step over, and etc. Okay, so that's about the interfaces. We talked about the syntax, and also it will be forbidden if you say new points, where point is an interface, right? For the reason that all the methods in the interface in an interface will not be implemented. So if you simply allow that, calling those methods will actually lead to crash. So that's why it's not allowed. All right, so we got the Cartesian points over here, and also we got polar points, right? We also spoke about them already. You can also read through the slide just to reinforce. All right, and that's the tester that we spoke about. Oh, one thing I didn't really say, but it's quite also straightforward. Let me tell you that. Question like, should this substitution be valid over here, right? Well, you should really answer this by yourself to know that, oh, I'll just tell you one. Can the dynamic type Cartesian points fulfill the expectation for the static type points, right? Well, you should know the answer, right? If you don't know, you should reach out to me. That's a very basic question about inheritance. That's why I said polymorphism over here. And dynamic binding is illustrated both on the paper and also on the Eclipse, right? So depending on what the current dynamic type is for the context objects, the corresponding version of the method will be invoked. Okay, so here are the simple exercises that you should really try to answer yourself. You will be expected at some point to actually write down some detailed responses that's written for your test or for your exam later. Okay, let's summarize what the interface is, and then we'll summarize when should you use interfaces and when should you use abstract classes. Okay, an interface has all its methods with no implementation bodies, right? You just put semicolon, pretty much like an abstract method without being declared as abstract, if that makes sense. And leaves complete freedom to its implementers. You can think about in the case of points, you got 2 implementers. You got the Cartesian points, and also you got the polar points. Each one of them got completely different implementation strategy. So that's why I said you got complete freedom about in a particular implementer class, how exactly you want to implement those methods that's inherited from the interfaces. Okay. So it's recommended to use an interface as a static type of, similar to the recommendation I made for abstract class, right? So for example, if you actually declare P to be of static type points, it gives you the flexibility to dynamically assign P to either Cartesian point objects or polar point objects. Alternatively, if you actually replace the point over here by Cartesian point, for example, in that case, you're restricting yourself to only Cartesian point dynamically, because the only descendant class for Cartesian point is Cartesian point, right? Similarly, if you got method parameter, you also want to be as general as possible, like as high as possible in the hierarchy, but you don't want to go too high. For example, like objects, so that'd be too accommodating. Okay, and also for the return type, also a point over here, right? And you'll be forbidden to really use the interface as the dynamic type, right? As we said. And instead, you want to create objects whose dynamic type are simply descendant classes of the interface, right? Exploit dynamic binding, like what we saw in the tester, right? So P can be dynamically pointing to Cartesian points, in which case P.getX will call the corresponding version in the Cartesian points. And if P is dynamically pointing to some polar points, and you will call other corresponding version of the method. Finally, let's summarize about when to use which. Okay, it's a very important question, but I can only give you some principle. The judgment call will still be up to you, right? You want to use the interfaces when there is a common set of functionalities, while each one of them will be implemented as a method. that can be implemented by a variety of strategies. For example, let's say in the case of the get x and get y, either you can implement it using the Cartesian point way or using the polar system way, right? Either way. So that's why I say a variety of strategies, at least two. And then, so for example, interface point declare the signatures or headers for get x and get y. We don't really commit at the interface level exactly how we're going to implement get x and get y. Only in the implemented classes, the subclasses, we actually commit to some strategy, right? You can see each descendant class represents a different implementation strategy, right? It's really important to see that. So it's really about strategies, different strategies for solving a problem, right? In general, every problem you're given to solve may simply have different solutions. Each one of them can just be an implementer for the problem. Alright, so Cartesian point implements its own way for get x and get y, and also for polar points, it also implements its own way for get x and get y. Right, that's about the general guidance for interfaces. What about abstract classes? I would say for abstract classes, you don't want to go for that extreme. You don't want to say all the methods are simply just abstract, like in the case of interface, right? You want to say if some implementation can be shared. For example, in the case of polygon, like a grow and also get parameter. So these two methods are those methods that can be shared by descendants, right? Just by sharing the same block of code. On the other hand, there will be some, but not all, implementation that cannot be shared. For example, like a get area. So that's why for the get area method only, we actually declare that as abstract in Polygon, and then we let either rectangle or triangle to implement their own version for the get area. So that's why for the new learners, maybe abstract class and also interfaces look a little bit similar. But if you think a little bit more deeply into it, it's not that similar. So you want to think about for all the methods you want to support for the parent class, are all of them going to be unclear about whether or not they should be supported at this level, like a get x and get y? In that case, use interface. Otherwise, if some of them can be supported, like a get parameter grow, in that case, you definitely want to have the abstract classes instead, right? All right, so let's say abstract class polygon. In that case, you get parameter. In that case, that can be shared by both a rectangle and triangle, and also declare get area. In which case, you don't really commit to how to implement it at the polygon level. You let the subclasses to actually implement it. Alright, so there's a very quick guidance about abstract classes versus interfaces. Study into them, and then you want to make sure you also study the example code to really get more idea about how things actually get connected together, right? Alright, finally, beyond this lecture, well, you want to study those two example Java projects, example interfaces, example abstract classes. And specifically, you may just want to practice drawing the inheritance hierarchy diagram. They should be very easy to draw. I even show you the solution already on the iPad, but it wouldn't hurt to do it again on a blank piece of paper. And also, more importantly, you want to use the debugger, as I showed to you in both cases, right? How to really use a step over and step into to really exploit, to explore how the dynamic binding happens at the runtime, for example. You can even feel free to actually extend the two example projects to include some typecasting. And maybe create yourself maybe some typecasting that wouldn't actually create any runtime class cast exception. Maybe some of them which will compile but will actually lead to class cast exception. Maybe some typecast that will even not compile, right? That's something we spoke about in the earlier inheritance lecture. That will be the kind of extra practice I would expect you to do. If you got any doubts about how to do that, you can reach out to me. Alright, so that's about the first topic I would like to discuss this week about abstract classes versus interfaces, right? Let's now move on to the next topic.